One of the applications of complex function is signal processing. Complex function and notation are very useful because it makes a number of signal processing concepts easier to understand. In signal processing, there is a term called complex signal. In signal processing, complex signal undergoes a process called filtration. The filtration process is conducted on both real signals and imaginary signals. This is the formula for filtration process. The HT function is the impulse response. The impulse response is multiplied to both real signal function and complex signal function. Impulse response can be either real or complex. This is an example of complex function that is often used when the impulse response is complex. The complex impulse response is a piecewise function which resulted in exponential complex function or returns a value 0.
Hi, my name is Nushamila Wazir. My metric number is 196161.
We have plane flying in a northerly direction at 300 km per hour, and there is a wind blowing toward the southeast at 30 km per hour. This is the formula of net velocity relative to the ground that will be the vector sum of these two vectors, where Vp is vector velocity for the plane and Vw is the vector velocity for the wind.
We got it from the parallel line of the plane and the parallel line of the wind. And this is the cross section where we got the resultant value.
We need to find the v of the plane in the x and y direction and the v of the wind in the x and y direction. The magnitude of how fast the plane could fly is we using formula where the r is equal to the square root of the x component squared plus with the y component squared. Now we need to know the direction relative to the positive x-axis, so the formula is P is equal to inverse tangent of the r sub y over r sub x.
Hi, I am going to explain about Fourier series. Sound waves are one type of wave that can be analyzed using Fourier series. Vibration of a physical object causes the musical instrument to produce sound, such as a string on a guitar or ukulele. Periodic variation in air pressure that is heard as sound is the result of this vibration. In Fourier analysis, a complicated periodic waveform x to the function of t can be written as a naught plus summation of ak cos 2 pi kt over t plus bk sin 2 pi kt over t. The period t is the length of time before the signal repeats, and the frequency f1 equal to 1 over t is the fundamental frequency or pitch of the note produced. When vibration occurs, not only f1 is produced, but other frequencies are produced as well, f2, f3, f4, and they are called the harmonics. Fourier coefficients a naught, ak, bk are the amplitudes of the sine and cosine functions corresponding to the kth harmonic having the same frequency 2 pi kt over t. Thank you.
Is the haziqah. My metric number is 196691. So the application for Fourier transform that I choose is digital image processing. Fourier transform is an important in this application which is used to decompose an image into its sine and cosine components. So let me proceed, and this is the digital image processing, and this is the simple image of a square, and the other one is the Fourier transform. The center of the Fourier transform plot represents the amplitude at the low frequency, sine and cosine wave that make up the image, while the outer regions represent the high frequency wave. So the formula for this application is fx equals with a naught over 2 plus summation from n equals to 1 until infinity n cos knx plus summation from n equals to 1 until infinity bn sin knx, or we can simply it as fx equals to summation from negative infinity to positive infinity, Cn e exponent I kn x. A0, An, and Bn or Cn can be calculated efficiently using computer algorithms, and Kn is equal with n 2 pi over L, which is L is the distance.